Okay, so this section is called rational expressions. And what we're going to be doing today is we're going to be simplifying a lot of rational expressions. What that looks like, a rational expression is simply the quotient of two polynomials. What I want you to maybe think of these as are fractions. Okay, I know you guys probably hate fractions, but I'm here to tell you that they're actually not that bad. So, speaking of fractions, why does 6/10 reduce to 3/5? Okay, well, the elementary answer might be simply, well, you divide both by 2. But think of it in terms of factors. Okay, what are the factors of 6? It's actually 3 times 2. What are the factors of 10? Well, that's 5 times 2. So yeah, you can say you divide both by 2, but you also have this 2 over 2 here, which actually cancel each other out, and thus you are left with 3/5. So if you can remember this, then this section is going to be super easy, because that's what the essential understanding from this section is all about. If you're simplifying a rational expression, including those that you multiply and divide, all you have to do is cancel all the common factors from the numerator and the denominator. Like we did there, we cancel the common factor of 2. Okay, so it's going to look scary, but it's not. What is x squared plus 7x plus 10 over x squared minus 3x minus 10, that's a minus sign, in simplest form? State any restrictions on the variables. Okay, all you have to do is figure out the factors. So factor this down. X squared plus 7x plus 10. Factors of 10 that make 7, positive 2, positive 5. Factors of negative 10 that make negative 3. Well, that would be negative 5 and positive 2. Okay, now before you cancel, state your restrictions. So now that you've got it factored, again, the restrictions come from the denominator. We talked about domain in the last video. Okay, x cannot equal, if you set these equal to 0, positive 5, and if you set that one equal to 0, negative 2. Okay, now that you've stated those restrictions, you cancel. Do we have a common factor anywhere? Yeah, we have an x plus 2 and an x plus 2. Okay, don't be silly. You can't cancel the 5s. You can't cancel the x's. Okay, up here, you could only cancel these because they were being multiplied. If this was 3 plus 5 over 5 plus 2, or why did I, 3 plus 2 over 5 plus 2, you couldn't cancel the 2's, right? 3 plus 2 over 5 plus 2. No, you can't cancel the 2's there because you're adding them. But when you're multiplying them, you can. So don't be silly, okay? Because you're multiplying these factors together, that's why you can cancel the entire factor out. And so you're left with x plus 5 over x minus 5. And that's the simplified form. Again, including the restrictions. Even though we canceled off that x plus 2, we want to include it in the restrictions, okay? Because originally we couldn't have negative 2, all right? So here are 2 more examples. Again, all you have to do is factor. Negative 8 that make positive 2, that would be positive 4 and negative 2. Positive 6 that make negative 5. Be careful. It's not 3 and 2. It is 3 and 2. Just kidding. It's not 6 and 1. Okay, because if you use negative 6 and positive 1, then this would have been a negative 6. Okay, so it actually is negative 3 and negative 2. Okay, again, include the restrictions. So before you cancel, x can't equal 3 or 2. Now you cancel, you see how you have an x minus 2 in both, and then you just rewrite what you have. X plus 4 over x minus 3. And then right next to it, just write x can't equal 3 or 2. All right? When you're not dealing with like a quadratic binomial or a trinomial or anything like that, and you just have things that are being multiplied, again, just remember the fraction problem. you can cancel things that are being multiplied. Okay? Now, 24 over negative 6, don't overthink that. That's a division problem. Okay? 24 over negative 6 is negative 4. All right? X to the third over x. Remember what this means. This means there are 3 x's in the numerator, 1 x in the denominator. You would cancel just one of those x's out. All right? So you have 2 x's left in the numerator. And then y squared over y to the third, you've got 2 on top, 3 on bottom. So 2 of them cancel 2 of the bottom out, and you're left with 1 on the bottom. Okay, and so that's what this one simplifies to. I forgot to include the restrictions right away. Just going back to this, we had an x in the bottom, so x couldn't equal 0, and y couldn't equal 0. Okay, when it comes to multiplying fractions, all right, again, how do you multiply fractions together? Well, you multiply straight across. Okay, so you've got 1 times 6 and 3 times 7. Okay, so you could just write this as 6 over 21. But again, think of the factors. What are the factors of 6? Well, that's actually 3 times 2. What are the factors of 21? Well, 3 times 7. And again, you can cancel the 3's, leaving 2 7s. Now, you could have done this before you even multiplied them together. And in fact, that makes this easier. If you were to break down this 6 right away into 3 times 2, this whole thing is like one giant fraction, so then you could have canceled the 3's right away. All right, leaving you with the 2 7s. That's what I want you to do with this. Factor everything first, and then cancel. Okay, x squared plus x minus 6 over x minus 5 times x squared minus 25 over x squared plus 4x plus 3. Factor. Okay, I told you factoring was never going to go away. X squared plus x minus 6, factors of negative 6 that make positive 1, positive 3, and negative 2. Okay, x minus 5 doesn't factor at all, so that's what we have there. Times x squared minus 25, difference of perfect squares. X plus 5, x minus 5. X squared plus 4x plus 3, factors of 3 that make 4 are 3 and 1. Before you cancel, include the restrictions. So looking at your denominator here, you've got a negative 5, x minus 5, x plus 3, x plus 1, so x can't equal positive 5, negative 3, negative 1. Now you get to go nuts and just completely cancel a bunch of stuff off. X plus 3's cancel, x minus 5's cancel. Okay, that's what you're, and then just rewrite what you have. And you don't need to FOIL this back out. X minus 2, x plus 5 over x plus 1 with these restrictions. Okay, that's all you have to do. And it's no different when you are dividing fractions. All right, when you divide rational expressions together, if you are dividing fractions, think about it. What do you have to do? Multiply by the reciprocal. So this is 3/4 times, flip the second one, 8 7ths. And again, think of the factors. Okay, well, what is 8? 8 is actually 4 times 2. Oh my goodness, you've got a 4. You can cancel it. So you're left with the 3 times 2 over 7, so 6 7ths. Okay, that's what you do with the quotients. Okay, with the dividing rational expressions. Just flip the second one, cancel your factors, just like we have been. Leave the first one, x minus 2, over. Factor it, factors of 1 that make 2, 1 and 1. Times, flip it, and factor it. Okay, so x squared minus 1, it was in the denominator, now it's going to be in the numerator, and when you factor it, it's a difference of perfect squares, so you get x plus 1 and x minus 1. In the numerator, you had x squared plus 3x minus 10. Factors of negative 10 that make positive 3 are positive 5 and negative 2. All right. And that goes in the denominator. Now, when it comes to restrictions, because we were originally having the x squared minus 1 in the denominator and now it's in the numerator, you still need to include its restrictions. Okay, so a lot of things x can't equal here. You get negative 1 from this over here, both of these. You get negative 5. You get positive 2 from these two. We already have the negative 1 from this one, but it also can't equal positive 1 from this one. So a lot of things that it can't equal. And now you get to go nuts. Cancel, cancel. Okay, so you're left with x minus 1 over x plus 1 and x plus 5 with all those restrictions. Okay. All right, I've got a couple problems to do on your own. That's what you have. Pause the video, do them, and then I'll show you the answers. Okay, there's the work and the steps. And I did forget that x can't equal 0 on this one because of the original x in the denominator. So that's what you have.